guys, today we're doing quantum numbers and we're going to go ahead and finish up chapter 2. Please, as always, let me know if you need help, okay? Alright, so before we start quantum numbers, I do want to preface this with there are a couple homework questions. There may be 2 test questions, but that's going to be it, okay? So there are 4 quantum numbers, and quantum numbers are related to electron configuration, really more to the orbital diagram. But in quantum numbers, it's more precise to tell us where the electron is than the electron configuration. So if we're relating it to like houses, electron configuration tells us what street we're on, but it doesn't tell us what house we are. Quantum numbers tell us specifically what house the electron is, okay, on a whole street. So we can pick any electron in the entire electron configuration, and we can find it with the quantum number. So again, there are 4 quantum numbers. The first one is N. They do always go in this order. The principal energy level, so that's just the coefficient. Okay, the second number is L, the angular momentum. That one is the block, so the SPD or F. If L is 0, we're S. L is 1 is P. L is 2 is D. L is 3 is F. P, S, D. Okay, and those numbers are set. The ML is a little bit more complicated. This has to do with the orbitals. Those are the lines. And then the MS is the spin, whether the arrow is pointing up or down when you draw the orbital diagram. So the principal energy number or energy level must be a whole number, and it must be greater than or equal to 1, and that's because on the periodic table we go 1 through 7. Okay, so on L, just remember S is 0, P is 1, D is 2, F is 3. These are just set numbers. Those never change. If we're in the L section, the D section, L would be equal to 2, or that second number. So here, what are the possible L values for N equals 3? So in 3, I've got 3S, I've got 3P, but don't forget about 3D. So L is 0, 1, and 2, C. So while D is technically on row 4, it belongs to the energy level 3. Okay, so you need to make sure you understand that. That ML, the third number, that has to do with the orbital or the lines. So here they're giving an example of D. It does go from negative L to positive L. So we know that D has 5 lines and D is 2. Sometimes I tell my students put 0 in the middle. So this is D. P would only have 3 lines. So if you put 0 in the middle and count out like a number line. S only has 1, it's 0. And then F will have 7 lines. It goes from negative 3 to positive 3. Okay, so this just tells us what line we're specifically on in the orbital diagram. The last quantum number is the spin. So if it is going up, the up arrow is positive 1/2 and the down arrow is going to be negative 1/2. Again, you will have 4 quantum numbers. Okay, and remember ML, that's the one that goes from negative L to positive L. So L is 2, so D must be ML. So again, when we're describing that orbital, we're going to use the first 3 quantum numbers because that tells me what line we're on. Okay, and again, N is the principal energy level or that coefficient. L is the sublevel or the block. And then our ML is our specific orbital. So here, principal energy level 2, so we're focusing here. L is 0, so we're in this section. Okay, for B, L is 1. We're still in energy level 2. And then we've got 3 orbitals to focus on. So here, what are the quantum numbers and names? For example, 2s or 2p, if our energy level is 4, so that means we're coefficient 4. Oh, and it says how many orbitals exist. So in 4, I've got 4s, 4p, 4d, but we also have 4f. Okay, so this one has 1 orbital, 3 orbitals, 5 orbitals, 7 orbitals. So this is 16 orbitals total if we were only looking at energy level 4. Quantum numbers associated with all 5D. So 5D, I would have 5 as my first. L would be 2 because D is 2. And then I could have -2. I could have 5 to -1. I could have 5 to 0. I could have 5 to +1. Or I could have 5 to +2. Because in my 5D, I've got 1, 2, 3, 4, 5. So it goes -2, -1, 0, +1, +2. Okay, and then how many 5D orbitals exist? There are 5 of them. Okay, so in general, what of the following is true? The number of sublevels within a level are going to be equal to n, so the blocks. The number of orbitals will be equal to 2l plus 1, and the total per level would be n squared. Some things about the different orbitals. S is spherical. That may come up, so just know that you make sure you know that S is a spherical shape. P has 3 orbitals, so they're in the different planes, px, py, pz. But here's an image. They kind of look like dumbbells. They have a node in the center. D has 5, and they get much more complicated at this point. They kind of look like clovers, or at least the first few do. This last one looks a little bit different. And this is much higher level math than you'll probably ever get to. And then F is even more complicated. They have 8 lobes instead of 4. So they kind of look more like a flower, the normal looking ones. All right, so that is it. If y'all have any questions, please let me know.